Today is for module 3, right? 21st of March. From cave to colosseums. We're going to talk about structure of the building. Okay. I will tell you a bit more why I call it cave to colosseum, because it's from primitive to one of the very advanced, right? First stage, we're going to do data gathering, right? The timeline in the Excel file, you know it. Submitted on the 26th of March, right? And then next week, we're gonna do the argument. We're gonna work together to set up good argument, and then for you to start writing, right? So it's very important you get the key idea, a good idea to write about first, then you write about it. Good idea must come from solid set of data, right? So we start off with data gathering. On the 4th, there are no lecture, no class, but I think I'm gonna give you the feedback on your essays. So I need time to work on that. And on the 9th, you improve your draft. Your draft we submit on the 2nd, right? And then on the 9th, a week, you submit the final essay. Or on the 9th, we might extend to 11 or 13 on the Songkran day, if you like. We can agree on that later. At the moment, let's fix, settle with this idea first. Okay. Now, what is structure? That's when you look at the building, the first question we should ask is, how does a building stand up? And how does a building take its form? To look at it is, right? Why the roof was, have incline into the slope like that, that we call the pyramid or pyramid gable form, right? How does the building stay in a rectangular form, right? The building can stand up if it has efficient structural support, right? The form of the building, the curve form, rectangular form, square, circle, irregular, it comes from the nature of its structure. Okay. If the nature of the form and structure were coherent, were in harmony, the building stays strong, right? So if you look at these images, right, you see the elements, the construction elements, column, rafter, right, and beam, right? All of it put together and to create a form and a space for us to use inside. In nature, form and frame structure will come together. Every form has structure. Even though, look at the worm, it had a caterpillar. It didn't have the skeleton, but the form has structure that keep it in its way. It's like a balloon, it have the internal force of air or liquid to keep that form stable, right? When we talk about structure, you have to understand this. If we talk about construction, we talk about the way we build things, the way we put each element together, right? That construction, we build the floor first, and then we build the roof or we build the roof first, or then we build the floor. That construction, how to build it, right? Structure is a set, is a system that how each component hold together. For example, if you look at the skeleton of the animal, right, they have a piece of bone, right? Every animal has a piece of bone, but the structure is the way each these bone were put together and help the animal keep it form. Once the form will keep stable, the animal perform or move in a different way, in its most efficient way, right? Like the frog could jump, the giraffe could hold its long neck and nibbling on the leaf of tree on high above the ground, right? So we talk about the elements, right? The bone, the elements, and the structure, the system, element and system, okay? The bone and the form of the skeleton, okay? So the fish have the bone as well. It have a different structure to help it swim quick in the water, okay? The same as the building, the same as the building. And if we look closely at each element, the joint, the continuing of bone or elements appear in a different way. Some building has a discontinuous joint. That means each bone were put together with certain muscle, or if you glue some element together, if you um, link it with screw or particular, or you weld it, you weld it like a steel, you weld it together. But when you weld it, you got continuous structure. The structure become the same piece. It didn't move. So it depends. You can look at it as this continuous joint is quite flexible, okay? Every piece can move on its own with the joints, a lot of joints. Of course, it's not as much as strong, not as much strong as the continuous structure. Example. Okay, that's the scope of essay. We come back later. Here is a image. So if we look at on the house on the right, each timber member, each timber membrane, right? Each element were nailed together, were linked together, right? So it seemed to be discontinuous joints, very flexible, easy to build, but not as strong as the castle, which is the stone and brick were bound together by mortar, or uh, think of it as a cement. It's similar to the cement, right? The mortar come from limestone, okay? Link that together into kind of one piece of stone wall, right? That be discontinuous structure, but they still, oh sorry, continuous structure. But at certain point, you can notice that they have this continuous structure, like the floor, which is separated from the stone wall, okay? So that example of continuous and discontinuous. So it gives it the strength to the building. Okay, so when we look at the building, we should see that, we should begin to observe that how the building were built. Okay, now look at the system of this other structure. This is based on Professor Angus MacDonald, right? The most fundamental is the frame structure. A post and beam. Post is column, right? Vertical one. Beam is horizontal one. Put together, right? Semi semi-form active is mean that this continuous joints, two discontinuous joint like the image B were put together to form a big one, to form a bigger system, bigger structure, right? Form active is the form, the structure that become the form and the structure, the way the weight will transfer to the ground were the same. Example of form active, the dome. The way the weight transfer from the top to the ground is along the curved line of the dome, right? Along it here. Yeah, along this line, right? And it's also a discontinuous, oh sorry, continuous joint, right? It's in one piece. We can see that in the natural form of the tortoise, right? So what do we have here? What do we have when when we we have this kind of structure? We have this space, right? The blue one. We have this space. The tortoise, that where their internal organ lay down. For human, this is for the use, right? So structure provide form. Structure provide form, of course, right? In the curvy form, and also provide space at the same time. And as we have studied last module, we know that human needs space to perform activities, right? So like this in Pantheon, right, is the temple of all god, of every god in the Roman ideal, right? Stay there, right? And this is represent like a universe, the sky, right? So they want this kind of space, so they choose the dome. And once the string of continuous joints and form active were put together to create a space that respond to their need, to their ideal of the heaven, the building become very unique, and it's like a masterpiece. It is the first of its kind. Okay. Right. So we're gonna study a history of space and structure, advanced structure in each period in the past until today. Okay. Now, okay. Look at this type of tortoise. Is not a form active, it's a semi-form active, right? You can see that they have a discontinuous joint, right? Observing from the plan of the skeleton. It gives a similar form, right, with the land tortoise, but this is a sea tortoise. It have a, and it has a roof, like look like a roof putting on the rib or the skeleton here. Okay, so if it's the same for the building, even though you have the same form, the structure might be different, and the strength and the way you use the space inside could be different. Now you have this rib as an element, right? But if you look at it, the space inside was so clean, very simple. So the different way they construct, the nature construct these animals amazingly. Okay. Now in architecture, we have structural elements. You have to consider nature of joint. Is it how strong is it, and what kind of materials they were used. So structural element and the system. If we look at this, okay, we see a frame beam, we see column, right? As the system is frame, post and beam, right? What about material? Timber, okay? That's simple. This house is in a medieval period. Okay, example of dome. Look at the form of the building outside. It look like a tank, right? But from the inside, it look like it in a spherical, look like the earth, right? It's an amazing building. Okay, a different kind of dome, the same form, but different way of construction, right? Different type of structure. Here the detail of the structure. It did not build with this continuous form and form active. It's a discontinuous joint and semi-form active. Okay, that means they put a piece of curve together, segment of the circle, right, together to form the half spherical dome. The Colosseum, from afar we look like we have oval form of stone, look like an egg, right? If you look closely, we see the continuous form, continuous joints of the auditorium. Auditorium means the space where the people sit down. Oh, sorry. This is auditorium, right? Where people sit. That the space they need to use, right? This is a space. So the structure is here, right? Sorry. The structure is here to provide the space here, right? For people to watch the entertainment. Okay, the structure is simple. Column, an arc, right? Arc is this curve, right? So this is not, in the way it look like post and beam, but the way arc is come to help, it allow us to have a long span. This is scale of human. Okay. Continue. In Gothic, the same. The dome was built again. The idea of dome, the idea of space, idea of form that they want to put emphasis on the church is still there. But the way they build the dome is different, right? Now they still use brick, stone and brick, but and also continuous joint form active. But the way they create form that help the dome have more strength, more is different from the design of a pantheon. Sorry, I'm not quite wake up yet. Now in Gothic, Gothic has a different idea of space, right? We see a lot of elements here. The key idea that I want you to study in Gothic is this space, vault, roof vault, the flying buttress. You probably have studied, right? In history of art. Okay. To build this in such a height, you know, they call God scale. For what? For they want the space inside, right? And look at the form outside. The form outside is, it looks sturdy, you know, very powerful, strong. But what about the space inside? Why do humans create just a space? And what kind of structure allow them to build, to have that space. Okay. Industrial revolution, industrial age. The main material, of course, metal, right? Or they call iron, cast iron or wrought iron, right? This is a Rostan structure to provide a form of like pyramidal like tower, right? The Eiffel Tower. This is the construction, right? How they build. The structure is frame, truss, what they call truss frame. Truss is when you put small element and weld it, link them together, right, to form a larger structure. Okay. Also, you can guess industrial revolution, right? Industrial age. But the look of the building, the space is the same as the cathedral, right? It's like a Gothic church, but the material is I think this is cast iron, cast iron, and glasses, right, to allow light to come in. So this kind of space was possible because of this structure. For those who may not know, right, the weight of the roof here going down along this rib, right, the metal rib, right, and it come down to the column, right, the column here, and the column transfer the weight to the ground. Okay, that the principle of frame structure. But the way this pointed arc were built allow stone to be performed in the same way as timber and steel. Right? That's the genius of the Gothic period. Okay. This is also steel structure 1858. Look very modern, right? It's the Royal Navy dock to keep the boat. Okay. Very simple architectural elements. You see that they use truss system here. Small piece of steel, not steel actually, cast iron to provide large long span, right? Still you have this column beam, right? Yeah. So you have large space to keep the boat, big boat, okay? So this is a mixed structure, this continuous joint, right? And made possible by steel and not concrete at the time, but uh, the frame, some other part of the wall would be brick. Okay, what else? What example do we have? Now, what type of structure do you think? Now, Utzon draw this. John Utzon draw these images of the Sydney Opera House, right? Very unique form, right? How can you build this form? What the structural system would you use? What kind of material would you use? Okay. This is a model, right? The space inside is for what? This is the stage, where they perform music, play, right? Like concert. And this is auditorium, right? Audience mean listener, right? Watcher, right? Audience, right? Torium, Om or Colosseum. Om in place, Colosseum in large, the large space, right? Auditorium, this is the space for audience, space for listening, right? EUM, Om, when you put that at the back of a word, it means the space, the place, okay? So they need this space, right, to perform. They also need this form to be a symbol of the Sydney, right? How did they build it in reality? Right? In reality, what what appeared to be the shell, in fact, it's a frame structure. They use precast concrete, right, to clad, over this steel frame. So in a way, it's used the same system as the house in the medieval period, okay? But the complexity of form that they build is it provides a different result, okay? So we're gonna look at the development of structure. If we look at the development of structure, we did not see the change in the structural system. We see the change development in joint, maybe in material, yes, right? And the way the precast concrete cladding were used. Cladding is the material, is this one. This is cladding, the outer shell cladding. This is the frame, and different size of frame of steel were used, right? And different way of joint were made, were designed. So that's the advance of the building, but not the structure, right? Somehow it's still amazing building, right? And that the construction, how they built it, okay? They use a big crane, build bit by bit, right? Okay. The other way to look at the structural elements, the classification of structural element, you can see the simple one, right? A timber plank or beam, wood beam, and then you began to see the improved form of the beam, like I-beam, truss system, right? Semi-form active, you see a simple one, laminated timber frame or trussed portal or frame, right? And the advanced form active is like a membrane of tensile structure. Like when you have a tent, right? A tent. The roof of the tent is tensile structure. It's a membrane that cover the space and provide a different form. Primitive structure elements, frame structure, right? And the elements is primitive because they got what they used from the nature. They did not refine these materials like bamboo, twig, or animal skins, right? They just use it as they got. That's why we call primitive. Prime is mean first, so first hand what they got, they use it in the first stage. Arc load bearing wall, semi-form active, right? Stone were put together with mortar, linked together, very strong. This is the elements of the wall, how they built it, right? You see this is the Roman detail of the Roman wall. Bronze clamp, the metal, were used in the structure long ago. The part of the metal were used in this thick brick wall because to consolidate, to help the wall stronger. Okay, so it is not the 20th century that architect and engineer know how to use metal to strengthen the building. Okay, now look at the space in St. Peter Basilica. huge space with vault. Vault is on the top, you know, curvy ceiling, long curvy ceiling we call vault. Right. How did they build that? What kind of structure? What kind of system they use? Okay. Of course, brick or stone, right? And they formed it. Vaulting is one of the structural system similar to dome. Okay. Material, tough, clay, unburned brick, timber, brick, stone, terracotta, metal. Later on, we have concrete. This is the material in the ancient world. Right? We found brick and mortar were used in Pompeii in Romans. Right? That's an example. Limestone were used thousands of years and still used it in many cold countries today. In Scotland, in Switzerland, they're still using it. Right? Concrete, pozzolana, the red concrete, the red materials. Right? The Roman engineer used this to build bridge because these material can concrete mean to become rigid, to become solid. It can become solid under the water, and it gives strength to the bridge, the Roman bridge and the Roman road. Right? Roof, terracotta, metal. Some metal was used to help strengthen the roof. Okay. If key elements were missing from the building, it would cause the building failure, structural failure, and it become dangerous and it cannot be used. So if you need a beautiful form, a good space, you know, wonderful space, you need to understand structure. Okay. Now, let's go back to our work. So the scope of the essay, I want you to choose the building that you like, you know, in their form, any type of building, right? But the key is I want you to look at each period from the ancient civilization. We talk about Romans, right? We talk about Mesopotamia. Ancient civilization, let's say prehistoric. Number one, let work on prehistoric. So it's become obvious. Prehistoric would be, you know, primitive structure, right? And then or cave, right? And then Roman is Pantheon, Colosseum. It's a lot of wooden frame house, right? And then we move on to Gothic, right? Vault, rib vault, right? Lots a lot of church, right? Industrial revolution, the change of materials, and then the modern movement in the 1920 and 30. Concrete were used, reinforced concrete were used, right? And in the late 20th centuries, and I believe that just about before you were born, right? It's a lot of advanced building with steel, tensile structure, glass were built, right? So you see the development of structure from this 6th period, okay? When you choose the building, you think of the system that you can compare, okay? You think of the material that you can compare, okay? And when you compare, I want you to identify the main space of the building. Like in the house, maybe the main space is the bedroom or the middle, the common room, the common space in the middle here, right? What is the form of the space and how would they build it, right? The structure that related to that space, okay? Read this article Okay, space and structure. This is a plan of the building of the house, right? You see, we have a main space in the middle here. This is fireplace. Okay, this is fireplace, right? We have main space here. Second, I can move it one is annotated. Okay, here we go. Try again. What kind of structure do we have here? Okay, we have this thick wall, right? Thick wall, right? And the roof is in a frame structure. Okay, so they provide what? They provide this space, one single room for living. Okay, so you need a section. This is called section. This is plan. I'm not sure if you know this already. Plan and section, right? T I O N, section. Okay, you need two images and maybe a photograph of the interior space that would help you. Okay, the book explaining about space and structure and how important the space is, right? They explain about amphitheater and the way, the limit of the Greek in the way they build amphitheater, right? If you want a larger space in Egyptian, the hypostyle hall, the hall of 100 columns, you have large building, but you did not have large clear space inside. Right? So Hagia Sophia want a large clear space inside. So they use a multiple dome put together to provide the key space here. This is the key space for worshipper, right? So in order to do that, they create the roof to cover this space, right? Okay. So if you choose this, you have to identify what is the structural system, okay? And what is the materials and how is it developed from the last period. Okay, the Gothic church, right? But this one is the modern church using modern material, steel and glasses. That the medieval house, right? Frame system. Okay, go and have a look and read it. Okay.